Hello students, let us study about chapter 2 structure of atom class 11th. First topic I am taking is Bohr's atomic model. Niels Bohr in 1913 presented a model of atomic structure which was based on the concept of energy levels or orbits. Its main postulates are: an atom consists of positively charged nucleus in the center and the electrons revolve around it in certain definite circular paths of fixed radius and energy. These paths are called orbits or stationary levels or fixed energy levels, or you can say shells. The stationary states for electrons are numbered as n equals to 1, 2, 3, 4, or we can say or write K, L, M, N, etc. Bohr's radius. The radii of these fixed energy levels are expressed as radii of the orbit, as you can see here in this slide. R is equals to n square h square upon 4 pi square me square multiply 1 upon z, or we can write 0.529 multiply n square upon z angstrom. You know children, you have studied that n is the principal quantum number, z is the atomic number, h is the Planck's constant. Now next is Bohr's energy formula. The energies of fixed energy levels can be given by the following formula, which is also known as Bohr energy formula. How we can write Bohr energy formula? We can write En means energy of nth shell is equals to minus RH upon n square or 1 upon n square. RH is Rydberg constant. Here again the formula you can see in different units, that is in kilojoule per mole and joule per atom. In joule per mole atom, the energy formula is minus 2.18 multiply 10 to the power minus 18 z square upon n square for hydrogen and hydrogen-like species, where the RH is substituted as 2.18 10 to the power minus 18. Next postulate is the energy of an electron in the orbit does not change with time. It remains in the particular orbit as long as it does not lose or gain energy. It explains stability of an atom. The next postulate is when an electron absorbs energy, it moves from lower energy state to higher energy state and again comes to the lower energy state or the ground state by emitting energy in the form of certain radiations. Next postulate is Bohr's frequency rule. The frequency of radiation observed or emitted can be calculated by the following formula during transition occurs between two energy levels. That is, nu is equals to del E upon H is frequency is change in energy divided by H. Change in energy or delta E is given as E2 minus E1, where E2 is higher energy level and E1 is lower energy level. The next postulate of Bohr is, according to Bohr's, the electron can revolve only in those energy orbits in which the angular momentum of the electron is quantized. It means whole number multiple of h upon 2 pi. It can be given as mvr is equals to nh upon 2 pi, where me is the mass of electron or m is the mass of electron. 9.1 multiply 10 to the power minus 31 kg. V is the velocity of electron. H is Planck's constant and R is radius. And what is L representing here? It is representing angular momentum of the electron. Now have a look over explanation of emission spectrum of hydrogen based on Bohr's model. When hydrogen atoms in the gas tube absorb the energy from the electric current, the electron becomes excited and it jumps from lower energy level to higher energy level. And when excited electrons fall back to their original levels, it emits energy as radiation. The emitted radiation received as spectral lines of specific wavelength or frequency. The spectrum consists of large number of series of lines named after their discoveries that appear in different regions of electromagnetic spectrum. The Maholay series of lines are the only line in the hydrogen spectrum which appear in the visible region of the electromagnetic spectrum. Now have a look over first 6 series of hydrogen spectrum. Right now you have studied Lyman, Balmer, Paschen. These series are visible here. Children, you can see Lyman series is observed in UV region, means ultraviolet region. Balmer series is observed in visible region, different colors, arrow you can see, which are representing the different radiations. Paschen series, which is observed in IR region. IR means infrared region. And here you can see the ground state, that is 1, n equals to 1, and others are excited state because the value of n is more than n equals to 1. And all these values in negative, for example for ground state, minus 13.6 are in the unit electron volt. Now Rydberg formula. Rydberg formula is given below by this mathematical expression. 1 upon lambda is equals to RH in the bracket 1 upon NF square minus 1 upon Ni square. What is RH? So you have studied in the previous slides also. RH here is the Rydberg constant. Constant value is also given. What is lambda? So you know children, lambda is wavelength, where NF is the final state and Ni is the initial energy level. Now, what are the limitations of Bohr's model of atom? Bohr's model is unable to explain fine lines in spectrum of hydrogen. It is unable to explain Zeeman effect, that is splitting of spectral lines in the presence of magnetic field. It is also unable to explain Stark effect. And what is the Stark effect? It is the splitting of spectral line in the presence of electric field. Bohr's model could not even explain multi-electronic system. It could not explain the ability of atoms to form molecules by chemical bonding. Now let us study a very interesting topic, dual behavior of matter. The French physicist de Broglie in 1924 proposed that matter exhibit dual behavior, that is both particle and wave-like properties. It means that just as the proton has momentum as well as wavelength, electron should also have momentum as well as wavelength. De Broglie give the following relation between wavelength momentum of a material particle, that is h upon mv, where m is the mass of particle, v is the velocity, and p is representing momentum of the particle. Dual nature of matter was confirmed when it was found that an electron beam undergoes diffraction, a phenomenon characteristic of waves. Every object in motion has a wave character. However, the wavelength associated with ordinary objects are so short because of their large masses. Therefore, their wave properties cannot be detected. Application of dual nature. The phenomenon of the dual nature has been put to use in making an electron microscope, which is based on the wave-like behavior of electrons, just as an ordinary microscope utilizes the wave nature of light. An electron microscope is a powerful tool in modern scientific research because it achieves a magnification of about 15 million times. Heisenberg's uncertainty principle. It states that it is impossible to determine the exact position and exact momentum of an electron simultaneously. Heisenberg's uncertainty principle is the consequence of dual behavior of matter and radiation, that is wave-like and particle-like. Mathematically, Heisenberg's uncertainty principle can be given as del x dot del p greater than equals to h upon 4 pi. I hope you understood. Thank you, children.